Hello class, it is me again, Professor Pat. Today we're going to be learning about the chain rule. Now before I want to talk about the chain rule, I want to retouch differentiation. So firstly I want to consider this function. F of x equals 8 times 2 minus x all raised to the third power. So if we distribute the 8 and expand the binomial, we get f of x equals 64 minus 96x plus 48x squared minus 8x cubed. Using the power rule, the constant multiple rule, and the rules for addition and subtraction, we can find the derivative of this function to be negative 24x squared plus 96x minus 96. Alright, we can factor to get negative 24 times 2 minus x squared. Now that's a lot of steps, right? So the chain rule exists to make functions like this one a lot easier to differentiate. Well, you may be asking, what is the chain rule? Well, the chain rule states if the derivative of y with respect to u is dy du, and the derivative of u with respect to x is du dx, then the derivative of y with respect to x is going to be dy of du times du dx. Basically, that's saying that if y equals f of u is a differentiable function of u, and u equals g of x is a differentiable function of x, then y equals f of g of x is a differentiable function of x. More clearly, dy dx, the derivative of y with respect to x, is going to be equal to dy du, the derivative of y with respect to u, times du dx, the derivative of u with respect to x. Therefore, the derivative with respect to x of f of g of x is going to be equal to f prime g of x times g prime of x. Right? So remember this function, f of x equals 8 times 2 minus x raised to the third. We're going to try it using the chain rule now. So the first thing we're going to do is we're going to let u equal g of x equal 2 minus x, right? So we'll get f of u or f of g of x, or even just f of x equals 8u cubed. Yeah? So the derivative of y with respect to u of 8u cubed is going to be 24u squared. The derivative of u with respect to x is going to be negative 1, right? So we know the chain rule states that the derivative of y with respect to x of y prime is going to be the derivative of y with respect to u times the derivative of u with respect to x. So we get our answer is negative 24u squared. We can't just leave it there. We need to substitute back in our 2 minus x for u, and we'll get the derivative of y with respect to x equals negative 24 times 2 minus x squared. If you recall, that's the same answer we got going the long way. Alright, so how can we use the chain rule in differentiation, you may be asking? Well, first I want to bring your attention back to some other rules of differentiation. I want you to remember the power rule. The power rule states that the derivative with respect to x of x raised to the power n, where n is a rational number, the derivative is going to be equal to n times x to the power of n minus 1. Something to note here, the derivative of x with respect to x is always equal to 1. So we can rewrite the power rule as the derivative with respect to x of x to the n equals n times x to the power of n minus 1 times dx dx, because 1 is the multiplicative identity value. Meaning anytime you multiply something by 1, you are going to get the same value. So we're going to combine the chain rule with this power rule to create a superpower mega chain rule. Unfortunately, I was not left in charge of naming this rule, and it was already given a name. It's called the general power rule. So the general power rule states that if y equals u to the n, where u is a differentiable function of x, and n is a rational number, then the derivative of y with respect to x is going to be n times u to the power of n minus 1 times the derivative of u with respect to x. So d dx u to the n equals n u to the n minus 1 u prime. Makes sense, right? So let's try using the general power rule to solve an equation. We want to differentiate f of x equals 3x minus 2x squared cubed using the general power rule. So how do we do this? Well, the first thing we're going to do is let u equal 3x minus 2x squared, which will make f of x equal to u cubed. All right, we know that the derivative of y with respect to u is going to be 3u squared, and we know that the derivative of u with respect to x is du dx, right? So we get the derivative of y with respect to x is going to be 3u squared du dx. Substituting out for u, we get 3 times 3x minus 2x squared times the derivative of 3x minus 2x squared, which is just 3 minus 4x, excuse me. So we get the derivative is going to be equal to 3 times 3x minus 2x squared times 3 minus 4x. And we got that using the general power rule, which is a combination of the power rule and the chain rule. All right, now we need to talk about trigonometric functions and the chain rule. So if you'll recall the rules for differentiating trigonometric functions, we know that the derivative with respect to x of the sine of x is going to be equal to the cosine of x. Derivative with respect to x of the cosine of x is going to be negative sine x, so on and so forth. Now recall, when I was explaining the general power rule, I reminded you that the derivative of x with respect to x will always be equal to 1. So these can all be rewritten as the derivative with respect to x of sine x equals dx dx times cos x. Remember, dx dx equals 1. So if we're using the chain rule, you'll recall that the chain rule states the derivative of y with respect to x is going to be the derivative of y with respect to u times the derivative of u with respect to x. Similarly, we could say that the derivative of y with respect to x for functions that don't have u, we could say dy dx times dx dx. So what we're going to do here, using the chain rule, we can determine the values of the trigonometric functions using the chain rule to be u prime times the value of the cosine of u for the derivative with respect to x of the sine of u. Same could be said all the way across the board. We take our value, we replace our x with our u, and we multiply by, instead of our derivative of x with respect to x, which is just 1, we're multiplying by our derivative of u with respect to x, which is u prime. Yeah? So let's consider this function. Y equals the secant of 2x cubed. First thing we're going to do is let u equal 2x cubed. Then we'll find that u prime is 6x squared, and y is going to be equal to secant of u. With this information, we know that the derivative with respect to x of the secant of u is going to be u prime times the secant of u times the tangent of u. So we get negative 6x squared times 2x cubed times the tangent of 2x cubed. The chain rule follows all your rules of differentiation. Once you become comfortable with the chain rule, differentiation becomes a lot easier. Chain rule opens up doors for implicit differentiation and related rates. And once you've got it down, it makes everything that much easier. Any questions?